Beneath the quiet rhythm of wind and water, Earth holds secrets it never meant to reveal. Secrets etched not in myth or language, but in patterns of carbon, fragments of metal, and subtle scars across the bones of continents. For centuries, we've walked atop ancient ruins without knowing they were there. Not temples or machines, but layers of time where something once thrived. Something intelligent. Perhaps even more intelligent than us. We tell ourselves a comforting story that we are the apex of Earth's long experiment with life. That our technologies, our art, our cities represent the first time consciousness has bent nature to its will. But deep beneath the surface, where pressure flattens history into stone, a different story may be buried. One with no names, no monuments, and no voices left to speak for it. The question is simple, yet its implications are staggering. Could Earth have once been home to a species more intelligent than we are now? Not just intelligent in the way dolphins play or crows solve puzzles, but intelligent in the way we build satellites and split atoms. Intelligent enough to change the planet and vanish without a trace. If such a species existed, what would they have left behind? A city erodes in centuries. Steel rusts. Silicon turns to dust. But the planet remembers in other ways. It remembers in isotopes, in atmospheric shifts, in the sudden absence or appearance of life in the fossil record. These are the fingerprints that time cannot fully erase. And so, we look to the rocks. In 2018, researchers re-examined ancient geological layers not for fossils, but for anomalies, strange chemical signatures that didn't belong. What they found was unsettling. Spikes in carbon, traces of synthetic compounds, patterns in extinction and rebirth that echoed our own time too closely. It was as if a cycle had played out before: rise, domination, collapse, silence. This is the heart of the Silurian hypothesis, a thought experiment named after a fictional alien race but grounded in real science. It asks, if an industrial civilization had existed millions of years ago, how would we find it? And more disturbingly, what if we already have and didn't recognize it? Because the deeper you go into Earth's history, the more peculiar it becomes. Great leaps in evolution appear almost overnight. Vast die-offs leave no clear cause. And always, in the quiet aftermath, a new kind of life emerges, more adapted, more advanced, as if nudged forward by something unseen. We stand at the edge of a long and silent past, staring into layers of stone like pages torn from a forgotten book. If something was once here, something that thought, built, dreamed, we must learn to see with new eyes. Because perhaps the greatest mistake we've made is believing we were first.
If there was ever another species like us, or beyond us, its legacy would not be made of monuments, not of towering spires or delicate machines, but of scars in the planet's chemistry. Because time does not keep statues, it does not preserve cities, it pulverizes everything into sediment, then hides the evidence beneath miles of shifting stone. And yet there are clues. Beneath the deserts of Namibia lie glassy mineral fragments, fused at temperatures no known natural event could produce. In ancient layers of sandstone in Australia, geologists have discovered peculiar spheres rich in rare metals, too symmetrical, too consistent to be volcanic. Scattered across Earth's oldest rockbeds, these anomalies echo with quiet insistence. Something happened here. But anomaly alone is not evidence. Skeptics argue that nature is full of surprises, that we should not leap to civilizations where geology may suffice. And they are right to be cautious. Our imaginations, after all, are too eager to populate the past with shadows. But still, what if these shadows are not inventions? What if they are echoes? Every industrial civilization must burn fuel. It must alter its skies. It must dig, refine, and discard. These actions leave fingerprints, not in steel or stone, but in isotopic ratios and molecular scars. And Earth, patient and indifferent, records them all. In ice cores pulled from Antarctica, scientists have found strange anomalies. Brief periods, millions of years apart, when greenhouse gases spiked rapidly and inexplicably. The air from those times carries the same chemical imbalances we are creating now. The warming patterns, the carbon signatures, they mirror the Anthropocene almost exactly. And then they vanish. Just as suddenly as they rise, they fall, leaving behind no known cause, no mass extinction, no meteor, no supervolcano, only silence. What could do that? Some suggest volcanism, or methane clathrates bursting from the ocean floor. Others whisper of civilizations lost, beings who reached an industrial age, altered their world, then fell. Whether by war, by accident, or by wisdom we never achieved, they disappeared, leaving behind only the changes they made to air and stone. To believe such a thing, we need more than mystery. We need intent, pattern, repetition. And the deeper we look, the more we begin to see. The fossil record, long thought a steady ladder of life, is anything but. Instead, it stutters, it leaps. Long periods of slow change, followed by sudden bursts of complexity. Entire phyla appear as if conjured. Then they vanish, as if dismissed. We call it the Cambrian explosion, the Ordovician radiation, the Great Dying. Events too vast to comprehend, too precise to ignore. Could these be the boundaries of forgotten epochs? If civilizations did rise and fall long before us, their only trace may be written in the very chemistry of Earth itself, buried beneath us, waiting.
Waiting for us to ask the right questions. If the stones remember, perhaps the cells do too. Deep within the genome of every living creature lies a history written in code. 4 letters repeating across millions of strands, whispering the story of life's endless improvisation. Evolution, we are told, is slow and patient. Mutation by mutation, it shapes the world. But what happens when the changes come too fast? What if the genome bears marks of something more deliberate? In recent years, geneticists have uncovered something strange. Segments of DNA that appear suddenly in evolutionary history, fully formed, highly specific, and without obvious precursors. These are not merely genes for wings or eyes, but regulatory sequences, commands that tell other genes when to activate, when to silence, when to build. Like software patches, they appear in the code and reorganize entire systems. They are called orphan genes, and their origin remains a mystery. One such gene, HAR1, governs brain development in humans. It emerged quickly, with no clear ancestry, shortly before Homo sapiens took their place on Earth. Another gene, FOXP2, crucial for speech, shows a similar sudden appearance, as though inserted rather than evolved. Could these be accidents of nature? Perhaps. But again, the pattern repeats. Sudden cognitive leaps, bursts of complexity, a mind that awakens too quickly as though guided. Some propose that these genes may be remnants, leftover strands from earlier intelligences, passed down like fragments of a forgotten language. If an ancient species had reached a level of biological mastery, could they have engineered their own successors? Could we be the product of minds long vanished? The idea is not new. Ancient myths from across the world speak of creators, not gods in the sky, but beings of flesh and intellect, who shaped humanity, taught language, gifted fire. Sumerian texts tell of the Anunnaki. Egyptian scrolls remember the Shemsu Hor, or followers of Horus, who ruled before kings. Hindu epics speak of vast vanished ages, where cities flew and weapons lit the sky like suns. Of course, mythology is not evidence, but myths persist for a reason. They survive because they echo something deeper, perhaps not facts, but memories distorted by time. Could it be that we are not the first to rise, but the last to remain? Biological evidence alone cannot answer this. Genes mutate, fossils vanish, but the possibility lingers, haunting the margins of science and memory. If we are inheritors rather than pioneers, what responsibilities do we carry? What mistakes are we destined to repeat? Because if intelligence has walked this path before, it may have fallen for reasons we are only now beginning to understand.
The universe, vast and indifferent, surrounds us with an unsettling question. Where is everyone? We scan the skies with telescopes and equations, listening for voices older than our sun. Yet the cosmos remains silent. No signals, no structures, no signs of life advanced enough to make itself known. This is the Fermi paradox, the contradiction between a high probability of intelligent life and the utter lack of evidence for it. But what if the silence isn't out there? What if the answer is here, beneath our feet, behind our myths, buried in the bones of the earth? It is a thought that chills even the most rational mind, that we may not be alone in the universe, because we were never alone on this planet, and that those who came before did not go to the stars, they vanished. Some physicists have speculated that intelligent civilizations might follow predictable arcs, rapid ascent, peak influence, then collapse. The reasons vary: ecological exhaustion, internal conflict, runaway technology, or a failure to navigate the very intelligence that lifted them above the natural world. They call it the Great Filter, the unseen wall that most civilizations never pass. Could Earth have already hosted such a rise and fall? We see patterns in our own world. Ecosystems collapse under pressure. Cities decay without maintenance. Technologies outpace ethics. And always the illusion that progress will protect us. But progress, too, forgets. In 1950, the American city of Detroit was hailed as the pinnacle of industrial achievement, an empire of automobiles and innovation. Just 50 years later, vast stretches of it were in ruins, skyscrapers overtaken by vines, concrete turned to dust. Multiply that decline by millennia, and even the greatest human monuments would vanish. And yet certain things persist. Radioactive isotopes from mid-century nuclear tests remain in soil across the globe. Microplastics have embedded themselves in every ocean floor. Carbon from our combustion engines has altered the very sky. These are the fingerprints of our time, and perhaps the only things future archaeologists might find. So we return to the rocks. In Greenland, ice cores reveal sudden climate shifts, eerily similar to our own industrial footprint. In deep ocean sediments, traces of synthetic compounds appear in layers predating human chemistry. And in ancient strata of rock across multiple continents, there are patterns, high levels of carbon, rare metals, isotope signatures that mirror what a global civilization might leave behind.
But if it happened before, why don't we know it? Because time is a ruthless editor. It erases, compresses, transforms. And because we have only just begun to ask the right questions. The stars may be silent, but perhaps they are waiting for us to recognize that the first contact we seek may not be with alien worlds, but with our own forgotten past.
Archaeology is the study of what remains. Stones, tools, bones, relics of lives once lived. But what if the most profound histories are those that left no clear trace? The archaeology of absence. If a civilization once flourished and vanished millions of years ago, how would we find its ruins? Would we recognize them or dismiss them as natural formations, coincidences, or even errors? Traditional archaeology relies on tangible artifacts, pottery shards, carved stones, inscriptions. But the deeper we dig into Earth's history, the fewer such clues we find beyond a certain point in time. The fossil record grows sparse. Geological processes recycle materials endlessly. What once was a vibrant city might now be a collection of minerals scattered and transformed beyond recognition. However, not all evidence is visible. Some scientists turn to geochemistry, searching for anomalies in isotopic ratios, signatures that defy natural explanations. These isotopic oddities hint at industrial activity, unnatural concentrations of carbon, strange distributions of rare metals, layers rich in synthetic compounds. For example, sediment cores drilled from ocean floors contain microplastic-like particles that date far earlier than humanity's plastic production. Some meteorites contain unusual mineral structures that resist natural formation processes. Even nuclear signatures pose profound questions. In Gabon, Africa, natural nuclear reactors operated 2 billion years ago, proof that nuclear chain reactions can occur without technology. But isotopic ratios in various geological strata show anomalies resembling those produced by nuclear weapons tests, yet these predate humans by millions of years. Could these be the fingerprints of ancient technologies? If so, why have we missed them? Because absence is easier to accept than paradox. Our scientific frameworks, built on assumptions of linear progress and uniqueness, are ill-equipped to interpret anomalies that challenge the narrative of human exceptionalism. The archaeology of absence asks us to reconsider what counts as evidence. It invites humility, to admit that our story might be only a chapter in a much older saga. And it demands vigilance, to look not just for what is obvious, but for whispers hidden in stone and sediment. For in those whispers may lie the key to understanding not just our past, but our future. Our atmosphere is a living record, a vast ledger inscribed with the breath of life across eons. Gases rise and fall, locked in ice cores and sediment layers, whispering tales of ancient climates, catastrophic events, and possibly the footprints of forgotten civilizations. Scientists studying ice cores from Antarctica and Greenland have uncovered puzzling episodes: sudden spikes in greenhouse gases, rapid shifts in atmospheric chemistry, and patterns that resemble modern industrial activity, but from times long before humans. For instance, layers dating back hundreds of thousands to millions of years show abrupt increases in methane and carbon dioxide, not easily explained by known natural phenomena, such as volcanic eruptions or wildfires. These atmospheric anomalies raise profound questions.
Could these be the echoes of an ancient civilization's energy use? A forgotten industrial age that altered the balance of gases just as we do today? Furthermore, traces of synthetic compounds, polymers, and plastics have been detected in deep ocean sediments and ice layers that predate human manufacturing by vast margins. Their molecular structures suggest advanced material science, exhibiting durability and resistance far beyond natural polymers. If these findings withstand scrutiny, they hint at a repeating cycle: rise, industrial flourish, environmental alteration, collapse. And yet, why such cycles? Earth's biosphere is a delicate balance, vulnerable to rapid shifts in chemistry. The very technologies that drive progress may sow the seeds of downfall. Atmospheric changes can trigger climate upheavals, mass extinctions, and reset the evolutionary clock. Could our current trajectory be just the latest verse in an ancient song? The atmosphere remembers. It holds the memory of past breaths, past fires, and past mistakes. Understanding these echoes is crucial, not only to uncover lost chapters of Earth's history, but to navigate our own precarious future.
Earth's history is punctuated by cataclysms, mass extinction events that have reshaped the tapestry of life. 5 major extinctions wiped out vast numbers of species, altering ecosystems and paving the way for new life forms. Yet the causes of these extinctions remain a subject of debate and intrigue. Traditional explanations point to asteroid impacts, volcanic eruptions, and climatic shifts, but some extinction events show patterns that defy simple natural causes. Take the Permian-Triassic extinction, the Great Dying, which eradicated over 90% of marine species around 252 million years ago. Geological records reveal unusual isotope anomalies and sudden atmospheric changes that some researchers speculate could indicate large-scale industrial or nuclear activity. Could advanced civilizations have played a role in these extinctions, or were they victims themselves? The concept is unsettling but worth exploring. If previous intelligent species altered their environment so profoundly, could their demise be written into these extinction layers? We see cycles of rapid devastation followed by bursts of new complexity, life adapting or evolving in the wake of catastrophe. This pattern could reflect ecological collapse triggered by technological hubris. Fossil records, atmospheric data, and geochemical signatures together paint a complex picture, one where nature and intelligence intertwine in ways we are only beginning to understand. Mass extinctions may not just be natural disasters, they could be echoes of ancient civilizations rising and falling, their fingerprints hidden in sight and plain. To decipher these layers is to uncover the fate of those who came before us, and to learn from their silent warnings.
Technology is the mark of intelligence. From stone tools to silicon chips, the artifacts we create shape not only our lives, but also the planet itself. Yet technology also fades. Without maintenance, machines rust, buildings crumble, and circuits corrode. So what remnants might survive millions of years? Recent studies suggest we should look beyond obvious ruins. Microscopic evidence, tiny metallic spheres, unusual isotopes, synthetic polymers, may be the enduring legacy of ancient technology. For example, titanium-rich spheres found in ancient sediment layers match particles produced by high-temperature industrial processes. These spheres have been discovered in strata dating back millions of years, long before humans mastered metallurgy. Similarly, layers of sediment contain synthetic compounds that resist natural degradation. Some even exhibit molecular structures more advanced than modern plastics. Radioactive isotopes from nuclear activity, unique signatures impossible to form naturally, have been detected in rock formations predating human civilization by tens of millions of years.
Could these be the fingerprints of ancient factories, reactors, or weapons? While traditional archaeology might overlook these clues, geochemistry and material science open new windows into the distant past. If civilizations arose and vanished, their technological remnants could be hidden in plain sight, disguised as natural anomalies. Recognizing these signals requires breaking free from assumptions that humanity is the first and only technological species. It challenges us to rethink history and the possibility of multiple industrial ages etched deep within Earth's record. Keep it approachable, as if you're sharing a fascinating story with a close friend. With every discovery, the question deepens. What does it mean if we are not the first? Knowledge carries a weight beyond science. It challenges identity, purpose, and destiny. For centuries, humanity has viewed itself as the pinnacle of evolution, the crown of creation. But if intelligence has risen and fallen before us, what does that say about our own future? Are we inheritors of wisdom or prisoners of repetition? History offers no guarantees. Civilizations collapse, knowledge is lost, and progress is never assured. The lessons buried in geological and genetic records urge caution. Our technologies, nuclear power, climate engineering, artificial intelligence hold immense promise and peril. We stand at a crossroads, facing challenges that ancient predecessors may have faced and failed to overcome. Understanding their fate could be our salvation or our doom. Could we break the cycle? Could we avoid the mistakes etched in stone and ice? This burden of knowledge is not just academic, it is existential. To accept that we may be the latest in a long chain of intelligent species is to embrace humility and responsibility. The future, like the past, is unwritten.
Science demands evidence, not speculation, but tangible proof. The quest to confirm ancient civilizations is a delicate balance between open-mindedness and skepticism. Researchers scour the planet, studying rock layers, ice cores, and sediment beds. Advanced technologies like spectroscopy, radiometric dating, and isotope analysis help detect anomalies invisible to the naked eye. But the greatest challenge is interpretation. How do we distinguish natural phenomena from artificial traces? How do we avoid bias, either dismissing evidence as coincidence or seeing patterns where none exist? Projects now investigate technofossils, remnants of technology that might survive deep time, such as microscopic synthetic particles or unique isotope ratios. Remote regions like Antarctica and the ocean floors offer pristine records untouched by recent human activity, holding clues from epochs we barely understand. Some scientists call for an interdisciplinary approach, combining geology, biology, chemistry, and archaeology to form a holistic view. The search is ongoing, sometimes frustrating, often controversial. But the possibility itself reshapes how we view Earth's history, not as a linear march from simple to complex, but as a vast, intricate tapestry woven with forgotten threads. If proof emerges, it will rewrite textbooks and challenge humanity's self-image. The implications are profound, a cosmic lesson about rise and fall, intelligence and fragility. Until then, the search continues, patient, persistent, and humbling.
History, whether written or hidden, is a mirror reflecting possible futures. If ancient civilizations existed and disappeared, their stories, lost to time, hold warnings for us today. Environmental collapse, Unchecked technological advancement and societal upheaval may be recurring themes. Their rise likely required mastery over energy and materials, but their fall perhaps came from overreach or neglect. We face the same crossroads now. Climate change accelerates, biodiversity declines, and geopolitical tensions mount. Will we heed the silent lessons etched in rock and ice, or repeat mistakes destined to erase us? Our challenge is to balance progress with stewardship, innovation with humility, to view ourselves not as masters of the earth, but as caretakers for its future. Ancient whispers remind us, intelligence alone does not guarantee survival. Only wisdom can.
As we stand on the precipice of an uncertain future, the lessons whispered by Earth's hidden past grow ever more urgent. The story we have traced, the rise and fall of civilizations lost to time, forces us to confront an unsettling question. Are we destined to follow their footsteps, or can we forge a different path? The planet beneath our feet holds memories etched not only in stone and ice, but woven into the very air we breathe and the living code inside us. These memories speak of great heights reached, of technologies mastered, and of hubris that shattered civilizations from epochs long vanished. The fossilized fragments and molecular signatures found in ancient rock layers suggest a repeating cycle, a cycle of emergence, dominance, environmental transformation, and collapse. But what if this cycle is not fixed? What if awareness itself is the key to breaking free? Our modern world, though young compared to the eons that preceded it, faces challenges unprecedented in scale and complexity. Climate change, biodiversity loss, nuclear proliferation, and the rapid advance of artificial intelligence converge in a delicate web that could tip either toward salvation or devastation. We wield powers that ancient species might have only dreamed of. Powers to alter atmospheres, rewrite genomes, and reshape ecosystems. Yet power without wisdom is perilous. The evidence of past industrial civilizations suggests they too faced crossroads. Their footprints in isotopes and synthetic compounds tell a story of innovation, shadowed by environmental upheaval. Did they ignore warnings? Did internal conflict or resource exhaustion doom them? Or did they choose to disappear, leaving the planet to heal? We do not know, but their silence echoes loudly. Here lies a profound responsibility, to learn from what is hidden, to read the subtle messages left in geology and genetics, and to understand that intelligence is not enough. Survival demands foresight, restraint, and an ethic of care. Science today becomes our guide and guardian. The multidisciplinary efforts to uncover technofossils, atmospheric anomalies, and genetic mysteries are more than academic quests. They are acts of remembrance and warning. By recognizing the fragile thread that connects us to past intelligences, we open the door to a future where humanity can choose stewardship over destruction. Our decisions now ripple forward like waves through time. We stand at a nexus where awareness can transform destiny. We are the first generation with the knowledge of this ancient pattern and the power to change it. Will we rise as guardians of tomorrow, honoring the lessons buried in Earth's ancient strata? Or will we become just another forgotten chapter in the planet's long, mysterious story? The answer rests not in distant stars, but within ourselves. The echoes of vanished civilizations call to us, not as ghosts to fear,
but as teachers to heed. Their story, once lost, may yet be the catalyst for our salvation.
As we delve deeper into the mysteries of Earth's past, one question arises again and again. How did life evolve with such sudden leaps, such rapid bursts of complexity that defy traditional evolutionary models? The Cambrian explosion, often described as biology's Big Bang, saw the sudden appearance of diverse, complex organisms almost overnight in geological terms. For decades, scientists debated how such a dramatic transformation could occur without clear precursors. Recent advances in genetics offer a provocative insight. Certain genes, known as orphan genes, appear abruptly in evolutionary history. They have no known ancestors and seem to encode functions that radically reorganize developmental processes. Genes like HAR1 and FOXP2, linked to brain development and language, emerged too quickly to be explained by gradual mutation alone. Some researchers speculate that these genetic leaps might be the result of intentional manipulation, biological engineering performed by an advanced intelligence long ago. Could it be that ancient civilizations, masters of technology and biology, shaped the course of life itself, not just by surviving and adapting, but by directly editing genomes, seeding evolutionary jumps, or even designing new species? This idea challenges the foundation of evolutionary theory, but offers a compelling explanation for sudden complexity and gaps in the fossil record. If intelligence shaped evolution, then our existence is part of a continuum, not an isolated event, but a legacy. Archaeological and geological evidence suggest multiple cycles of rise and fall, each leaving subtle traces in DNA and sediment layers. We may be inheritors of knowledge and biology far older than we imagine. The concept of hidden architects forces us to reconsider humanity's role. Are we the pinnacle or the latest creation in a chain of crafted intelligence? Understanding this may redefine what it means to be human. To explore our origins is to explore the nature of intelligence itself, how it interacts with life, environment, and time. And it invites humility, acknowledging that the story of life is not only written in stone and gene, but in the hands of unseen creators who once walked this earth.
The universe is vast, filled with billions of stars and countless planets, yet we hear no echoes of other intelligent life. This silence is known as the Fermi paradox. Among the proposed answers is the idea of the Great Filter, a stage or event so difficult to overcome that few civilizations survive it. Could the rise and fall of ancient Earth civilizations be the evidence of this filter? Perhaps advanced species inevitably reach a point where their technological prowess outpaces their ability to control it. Nuclear weapons, environmental destruction, artificial intelligence, each holds the power to elevate or annihilate. The geological record hints that ancient civilizations may have encountered this crossroads. Sudden climate upheavals, mass extinctions, and strange isotope anomalies could be signatures of civilizations reaching and failing the Great Filter. If so, humanity faces the same challenge. Our current trajectory is fraught with risk, but also possibility. The knowledge we gain from Earth's buried past could be the very key to passing through the filter. We must learn to wield technology wisely, balance growth with sustainability, and cultivate resilience in the face of uncertainty. There is no guarantee that intelligence will survive. Evolution favors adaptation, not perfection.
But if we understand the pattern, if we recognize the echoes of past mistakes, we have the power to rewrite our story. We stand at a unique moment, armed with ancient wisdom rediscovered through modern science. To transcend the filter, we need more than technology. We need foresight, ethics, and cooperation on a global scale. The silence in the cosmos may be a warning or an invitation. Will we be the civilization that learns, adapts, and endures, or another lost chapter in Earth's deep history? The choice is ours, and the stakes are nothing less than the future of intelligent life on this planet.
Every civilization, no matter how advanced, leaves a legacy. Sometimes that legacy is monuments carved in stone or sprawling cities visible from space. Sometimes it is whispered in the elements, scattered through soil, air, and water. And sometimes it is hidden, forgotten by time, but waiting patiently to be discovered. Our own legacy is already taking shape. Satellites orbit the Earth, beams of radio waves pulse into the void, and plastic particles settle into the deepest ocean trenches. We are writing a story in elements and isotopes, one that future geologists and archaeologists will read. But what story will they find? Will they see a species that flourished and faded, a spark of intelligence lost in the vastness of time? Or will they discover a civilization that learned from the echoes of the past and changed its destiny? The fossil record is incomplete. The geological layers hold mysteries, and the possibility of forgotten intelligences demands that we keep questioning. As custodians of this planet, we bear the responsibility not just to survive, but to thrive sustainably. We must confront the limits of our technology and the consequences of our actions. The ancient civilizations that may have preceded us, if they indeed existed, show us both the heights intelligence can reach and the dangers it brings. Our future depends on understanding this duality. Will we continue the cycle of rise and fall, or will we break free, becoming truly wise stewards of Earth and perhaps the universe? The legacy we leave behind is not just for ourselves, but for all life that follows. In the silence of deep time, our story is still being written.
As we ponder the possibility that Earth has hosted intelligent civilizations long before humanity, it is natural to look beyond our planet to the vast expanse of the cosmos. The Silurian hypothesis not only challenges our understanding of Earth's past, but also reframes our place in the universe. If civilizations can rise and fall here, might similar cycles be occurring elsewhere among the stars? Our search for extraterrestrial intelligence has so far yielded silence, a paradox that puzzles scientists and philosophers alike. Perhaps the answer lies in the Great Filter, a cosmic hurdle that many civilizations failed to overcome. Studying Earth's ancient records may offer clues about this filter's nature, revealing the fragile balance required for a civilization to endure. Moreover, the traces of past Earth civilizations remind us that technological advancement does not guarantee permanence. Intelligence must be coupled with sustainability, foresight, and humility. As we extend our reach into space, carrying the legacy of life on Earth, we bear the responsibility to learn from the echoes of the past. Our stewardship of Earth and our cosmic ambitions are intertwined. The future of intelligent life, whether on Earth or among the stars, depends on recognizing the lessons buried deep in time. The story of vanished civilizations is not just a cautionary tale, but a call to action, a reminder that we are part of a grand, ongoing experiment in intelligence and survival.
Civilization, despite its grandeur and achievements, rests upon a delicate foundation. From resource management to social cohesion, from environmental balance to technological control, each element is vital for sustained survival. History, even the brief history of humanity, offers countless examples of societies collapsing due to drought, war, disease, or economic failure. If ancient civilizations existed on Earth before us, their downfall might have stemmed from similar vulnerabilities, amplified by their industrial might. The geological record hints at sudden disruptions, mass extinctions, isotope anomalies, and abrupt climate shifts that coincide with periods of possible technological activity. These may represent civilizations that reached great heights but faltered under the weight of their own progress. The lessons are stark. Intelligence and technology alone do not secure a future. Without sustainable practices and adaptability, even the most advanced societies risk oblivion. In contemplating the Silurian hypothesis, we must reckon with the fragility inherent in any complex civilization. Our own global society faces unprecedented challenges: climate change, nuclear risks, pandemics, and rapid technological change. Understanding how past civilizations may have failed can illuminate paths toward resilience. It demands humility, long-term thinking, and a commitment to steward both our environment and our social fabric. The story of forgotten civilizations is a mirror, a reflection of what might happen if we ignore the delicate balance required to endure.
Oceans cover more than 70% of Earth's surface and hold some of the planet's most pristine geological and biological records. Their depths are time capsules, preserving sediment layers untouched by human disturbance. Scientists have turned to deep-sea drilling projects to unearth clues about Earth's distant past. In sediment cores extracted from ocean floors, researchers have discovered anomalous particles, microscopic metallic spheres, unusual isotope ratios, and synthetic compounds, some dating millions of years before humans appeared. These particles resemble industrial pollutants and synthetic plastics, materials thought to be exclusive to modern human industry. How did they get there? Could they be remnants of prior civilizations' activities? Or are they natural phenomena, yet to be fully understood? The ocean's depths guard secrets that challenge our understanding of history. Moreover, the unique conditions of the deep sea, low oxygen, cold temperatures, and stable environments, allow certain materials to persist far longer than on land. This preservation offers hope that future studies might uncover definitive evidence of ancient technological activity. Yet the interpretation of these findings remains controversial. Skeptics argue these anomalies may result from unknown geological processes, contamination, or measurement errors. Believers contend they are the fingerprints of civilizations lost to time, urging deeper interdisciplinary research. The ocean's silent layers are a frontier, a repository of history waiting to be decoded. As technology advances, we may soon peer deeper into these archives, illuminating the hidden chapters of Earth's story. The search continues, inviting us to listen closely to the echoes beneath the waves.
Throughout Earth's history, catastrophic events have shaped the trajectory of life and civilizations. Massive volcanic eruptions, asteroid impacts, climate shifts, and sudden changes in ocean chemistry have repeatedly rewritten the planet's story. If advanced civilizations existed in the deep past, they too would have faced these immense challenges. The Permian-Triassic extinction, often called the Great Dying,
wiped out over 90% of marine species around 252 million years ago. Recent research reveals anomalies in carbon isotopes and radioactive elements from this period, signatures that some speculate could be linked to industrial activity or nuclear events far predating humanity. Could such cataclysms have been accelerated or caused by civilizations pushing planetary boundaries too far? Alternatively, might these civilizations have collapsed due to these natural disasters, their fate intertwined with Earth's volatile systems? Catastrophes, while destructive, also clear the stage for renewal. They reset evolutionary clocks, allowing new life forms and perhaps new intelligences to arise. This cycle of collapse and rebirth may be a fundamental pattern, not just in biology, but in civilization itself. Understanding how past catastrophes affected Earth, or were affected by intelligent life, adds depth to the Silurian hypothesis. It suggests that survival depends not only on technological prowess, but on resilience and adaptability to the unpredictable forces of nature. As we face our own potential catastrophes, this ancient pattern offers both warning and hope. The future may depend on how well we learn to live with uncertainty and change.
The quest to uncover Earth's hidden past is more than an academic pursuit. It is a profound responsibility. If we confirm that advanced civilizations existed before us, their stories become our own cautionary tales. Science must tread carefully, avoiding sensationalism while embracing curiosity. Discovering evidence of prior civilizations would challenge not only our history books, but our very identity. It would reshape how we view progress, intelligence, and humanity's place in the cosmos. The search encourages humility, reminding us that we are part of a much larger continuum. It demands that we reconsider how we manage technology, environment, and society. With this knowledge comes the imperative to act wisely. The future is a blank page, but the past offers ink and lessons. As stewards of Earth, we must honor the memories buried beneath our feet by striving for a sustainable and enlightened civilization. Our legacy may well depend on how we interpret the echoes of those who came before, and whether we choose to learn from them or repeat their mistakes. The story is still unfolding.
The whispers from Earth's deep past urge us to reflect, not just on who we are, but on who we might become. If civilizations before us reached pinnacles of intelligence, technology, and industry only to vanish into oblivion, their fates serve as silent teachers. What caused their downfall? Was it a failure to respect natural limits, a loss of social cohesion, the misuse of powerful technologies beyond their control? These questions echo louder today as humanity faces environmental crises, geopolitical tensions, and the accelerating pace of innovation. The geological record shows that Earth's systems, climate, oceans, and atmosphere are deeply interconnected and exquisitely sensitive. Ancient civilizations, if they existed, had to navigate this delicate balance, just as we do. Their traces, anomalous isotopes, synthetic compounds, rapid environmental shifts suggest their industrial activity had profound planetary impacts. Yet despite their knowledge and power, they disappeared. Was their extinction abrupt or gradual?
Was it triggered by natural catastrophe, technological mishap, or societal collapse? We may never know all the answers, but their silence is a powerful message. Our era is unique, the first to possess the scientific tools to detect these ancient signatures, to unravel the stories hidden in stone, ice, and sediment. This knowledge places a heavy responsibility upon us. It demands that we act with foresight, humility, and care. Technology can be a force for survival or destruction. It is our choices that determine the path. Learning from the past means embracing sustainability, fostering global cooperation, and respecting the limits of our planet. It means recognizing that intelligence alone does not guarantee endurance. Wisdom must guide progress. As the newest chapter in Earth's long story of life and civilizations, humanity has the opportunity to break the cycle, to become not just a fleeting spark, but a lasting flame. The echoes from vanished civilizations remind us that the future is not predetermined. It is shaped by our actions today. By choosing responsibility over recklessness, collaboration over conflict, preservation over exploitation, we honor those who came before and ensure a legacy for those yet to come. Our story is intertwined with the planet's fate. In listening to the silent testimony of the past, we find the inspiration and warning to build a sustainable future. The question is no longer just if civilizations existed before us, but whether humanity will endure to write the next great chapter.
The quest to find undeniable evidence of past advanced civilizations on Earth is as daunting as it is fascinating. Unlike ruins from recent human history, which remain visible for thousands of years, any traces of ancient civilizations millions of years old would be almost impossible to detect with traditional archaeology. Erosion, plate tectonics, volcanic activity, and biological decay have relentlessly recycled Earth's surface, erasing most surface-level artifacts. That's why scientists turn to geology, chemistry, and paleontology to search for indirect evidence, subtle signatures embedded deep within Earth's strata. For example, unusual isotope ratios, such as carbon, uranium, or plutonium found in ancient rocks, might hint at nuclear activity long before humans. Microscopic metallic spheres or synthetic polymers embedded in sediments challenge the assumption that such materials are exclusively human inventions. However, distinguishing these anomalies from natural phenomena or contamination remains a significant hurdle. The interpretation of such data requires cross-disciplinary collaboration, meticulous analysis, and often creative thinking. Cutting-edge technologies like high-resolution mass spectrometry, deep-sea drilling, and ice core sampling enable us to peer further back in time than ever before. Yet, skepticism remains healthy. Science demands rigorous proof, and extraordinary claims require extraordinary evidence. The Silurian hypothesis invites us to broaden our perspectives while maintaining critical scrutiny. What if some geological features we attribute to natural causes are actually remnants of forgotten civilizations? Could there be fossils of technology, molecular imprints, or landscape modifications yet unrecognized? Emerging research fields like geoarchaeology and astrobiology provide new frameworks to explore these questions. They encourage us to consider planetary history as a complex narrative, where life and intelligence have risen, influenced environments, and faded multiple times. The search for proof is ongoing and evolving. It challenges assumptions, fuels debate, and expands the boundaries of what we consider possible.
Ultimately, it is a quest not just to understand the past, but to better comprehend our place within Earth's grand story.
The idea that Earth might have hosted intelligent civilizations before humanity forces us to confront profound philosophical questions. What does it mean to be the first or the only intelligent species on our planet? If advanced beings rose and fell long before us, how should that reshape our understanding of intelligence, progress, and the nature of life? This possibility challenges anthropocentrism, the belief that humans are the center and purpose of existence. It humbles us, suggesting that intelligence may be an emergent property of life, cycling through epochs, not a singular achievement. Furthermore, it prompts us to reconsider the linear narrative of progress. History, both human and planetary, may be cyclical, marked by rises and falls, awakenings and extinguishments. If so, our current civilization is but one iteration in a much larger continuum. This perspective may foster greater humility and responsibility, recognizing that we are part of an ongoing process rather than a final destination encourages stewardship over domination. It also invites openness to possibilities beyond current scientific paradigms. Might some knowledge or technologies be lost to time, awaiting rediscovery? Could there be wisdom in ancient patterns that inform our future choices? The Silurian hypothesis is more than a scientific theory. It is a philosophical challenge. It asks us to expand our worldview, to embrace uncertainty, and to respect the deep time that frames our existence. Ultimately, it can inspire a sense of connection with the past, with the planet, and with the cosmos. By acknowledging the potential legacy of prior civilizations, we deepen the meaning of our own.
The search for traces of ancient civilizations stretches the boundaries of science and technology. Today's explorers are not just archaeologists or geologists. They are multidisciplinary teams employing satellites, robotics, AI, and deep Earth drilling to peer into Earth's hidden history. Space missions, too, provide complementary insight. By studying other planets and moons, scientists learn about planetary evolution, environmental extremes, and possible habitats for life, informing how civilizations might arise or perish elsewhere. The rapid advancement of technology has revolutionized our ability to detect subtle anomalies in Earth's geological and chemical records. High-precision instruments analyze isotopes, trace elements, and molecular structures at microscopic scales, uncovering signatures previously invisible. Remote sensing from orbit maps geological features with unprecedented resolution, identifying unnatural patterns and mineral deposits that could suggest past industrial activity. Deep sea and ice core drilling projects bring ancient sediments to light, preserving materials that reveal environmental shifts and synthetic compounds millions of years old. Future missions plan to explore the moon's subsurface for preserved human artifacts, and even the Martian surface for evidence of extinct life or civilizations. Such endeavors underscore the interconnectedness of planetary sciences and the search for life, past or present. They also expand the context of the Silurian hypothesis beyond Earth, inviting speculation about lost civilizations across the cosmos. Yet the most profound discoveries may lie just beneath our feet, in the quiet layers of Earth's crust, waiting for us to decode their secrets. As we push forward, every new tool and mission holds the potential to rewrite history, challenge assumptions, and inspire wonder. Our journey into the past is just beginning, and with each step, we come closer to understanding not only who came before us, but also
what our future might hold.
After exploring anomalies buried in ancient stone, after chasing synthetic traces across the ocean floor and radioactive whispers locked in ice, we are left with a haunting final question. Are we next? If Earth has hosted advanced civilizations before, if they rose to greatness and vanished into silence, what makes us believe we are immune to the same fate? We sit on the edge of technological wonder, quantum computers, space travel, artificial intelligence, yet also on the edge of environmental collapse, resource depletion, and geopolitical fragility. The patterns we see in the geological record, rapid industrial signatures, sharp climate shifts, sudden mass extinctions, mirror our present moment with eerie precision. If ancient civilizations disappeared, perhaps not from war or invasion, but from internal imbalance, then we must ask, are we repeating a cycle written long ago? What we call progress may also be acceleration toward a threshold we do not fully understand. The Silurian hypothesis does more than suggest a forgotten past. It shines a mirror upon our future. It tells us that intelligence, unchecked, does not guarantee survival. It urges us to slow down and listen to the planet, to the data, to the lessons carved into Earth's ancient bones. And in doing so, it grants us a chance that those before us may not have had, the chance to choose a different path. We are the only known species to question our own trajectory, to study extinction while still alive, to hold in our hands both the seed of destruction and the tools of salvation. The final legacy of any civilization may not be its towers, its machines, or its monuments, but its wisdom. And wisdom begins with listening to history, to the earth, to the silence left behind by those who came before. Because perhaps they too once asked, "Will we be remembered?" And now, across the layers of stone and time, the answer depends not on them, but on us.
Beneath every layer of sediment, beneath every fossilized trace of life, beneath the silence that time has pressed into stone, lies a question. A question that has haunted every civilization that ever stood beneath the same stars. Were we the first? We have searched the oceans, the ice, the mountains. We have measured the isotopes in ancient rock, mapped synthetic particles buried beneath millennia, and read chemical signatures that no natural process can explain. And though no monument remains, though no language, no cities, no names endure, the earth remembers. Not with words, but with patterns. Not with stories, but with scars. If other civilizations came before us, intelligent, brilliant, capable of shaping the world, they are now dust. Not because they lacked power, but perhaps because they forgot what truly matters: balance, restraint, time. And so we return to ourselves, to this moment, to the species that built telescopes and probes and asked not just how we exist, but why. We are not the masters of this planet. We are its most recent memory. And if we are wise, we will not be its last. Because the earth does not care about monuments. It does not preserve power or pride. But it does remember patterns. And if we listen, truly listen, we may yet break the cycle. Perhaps we are not the first, but we might be the first to remember.